Now, two exercises related to isolated converters. This one here starts out with the high side MOSFET and a low side MOSFET connected together in a half bridge. Both of them have their body diodes here and there. And to begin with, they drive simply an inductor. The power stage is supplied by a balanced voltage supply formed by the two V-in sources. The operation of the devices is alternating. Either device A is turned on or device B is turned on. First of all, you are asked to draw the voltages and the currents V1 and I1. Then you're supposed to model the inductor series resistant if the inductor is dissipating 3 watts. Afterwards, we change the circuit into an isolated converter by using a transformer. And the question to you is, how do the diode currents ID3 and ID4 look like in that full bridge rectifier if the load is simply shorted? In the next step, this exercise develops by adding a 20-volt DC voltage source at the output instead of the short. That means the circuit now looks like that, and you are asked about V3 and I3 in the 4 different operating cases. And in the last part of the exercise, you're supposed to change the operating times of the 2 switches so that the inductor current peaks at 10 amps and at minus 10 amps. And you're supposed to find out how long do you need to turn on the transistors and what's the operating period. And in the second exercise, we are dealing with an ideal flyback converter with these operating conditions here in discontinuous conduction mode. What is the peak input current, and also draw that input current, and remember to put numbers on the axes. What's the average input current, and how much power do we have at the input? And finally, draw the diode current. Furthermore, what's the output current? Draw the voltage across the primary side of the transformer, and also draw the diode voltage. What's the RMS value of the current through the diode? And what's the RMS value of the current through the capacitor?